Welcome to this short technical video on harnessing the power of discriminators in the BIRD logical data model. So this is quite a technical presentation, but we discuss the BIRD logical data model and its use of discriminators. We'll try to demystify that concept if you're not familiar with them. The BIRD logical data model uses a technique called inheritance or subtyping. And from that model we apply some processes to make a different style of model that's more relational called the input layer. But today we'll focus only on the BIRD logical data model and its subtyping. We'll use it as an example. Here in SQL Developer we have the logical data model open, and we'll have a look at the instrument table here, or instrument entity. We can go to the diagram here. See the instrument entity has these attributes, and the red lines are what we call subtypes. Now this table, or this entity, has what's called two disjoint subtypes. So not only is it subtypes, but the subtypes are split into two groups. The two groups are determined by this, what we call arc here. And this first arc is called instrument by product, and this other arc that groups together subtypes is called instrument by origin. Now we always notice that for each arc there will be an attribute that we call a discriminator in the entity. So instrument type by product, we'll say for this entity which, when we instantiate it or put some data in here, which subtype has actually been used from the subtypes for product, and also which has been used for the subtypes for type by origin. So what do these subtypes look like? Well, we can follow these red lines to find the subtypes. Here, for example, is loan and advance. But there's an easier way to do it also, which is because we have what's called a subview already created. We can look at it here. So instrument type by product. This for one of those arcs, we see the instrument has these subtypes of loan and advance, deposits, securities finance transaction, off balance, etc. And those have other subtypes also. So here we can see the instrument, here's we're just looking at one arc, one set of subtypes. If we were to look at one of these things like a loan and advance, let's have a look at it. Loan and advance. See, it has two subtypes, but also if we look at the diagram here, we'll see it's not got subtyping. All the subtypes are in one arc, so it's not got disjoint subtypes, it's only got subtypes in one arc, and that again has a discriminator called loan and advance type. And we can see the logical data model itself is very big. It has lots of subtypes and lots of disjoint subtypes. And we want to understand a bit more about these. We often find what we do is colour code the LDMs. All these things in green relate to instrument related entities and subtypes. Blue is something else. Light blue is something else, etc. Dark blue I think is securities. So let's have a look at how we can navigate some useful information about discriminate, and we can do that with the discriminator navigator in Eclipse FreeBIRD Tools. It's easy to find. You go to the GitHub site for Eclipse FreeBIRD Tools, which is a branch called Feature LDM Cube Generator, and we just do this code plus, and it will start up with what's called a code space. It's like a web-based view of this information, so you don't need to install anything locally, which is good, so you don't need to ask for permissions or do a lot of setup. This does take about a minute to start, so I'll pause the video. Okay, now we click open in browser and we'll see the FreeBIRD application start up. We'll choose workflow dashboard, which can do many things. We'll describe that we're using the logical data model. I'm going to get information from a repository called FreeBIRD 66, which has, amongst other things, the export CSV files from SQL Developer for the logical data model. We shall save our configuration. Then we're going to click Retrieve Artifacts to go and get those artifacts from that GitHub repository. Then I'm going to click Set Up Database, and this will create a database using a database server called SQLite, the database technology. It can use other databases also if it's configured to do so. This will take about 2 minutes because there's a lot of entities in our LDM, but it'll create a database, a relational database, but following standard techniques of how to express subtyping in a relational database. Okay, with that database created, we could enter the main workflow and create transformation rules in a format called smcubes, change those to Python rules, automatically execute a test suite. But what we're interested in here is the discriminator viewer. So here we choose an entity, and we should choose like a useful root entity, one that's near the top. And we'll see this set of possible allowed combinations of discriminators. So this is quite interesting. We'll see, we're starting with instrument. We remember that there was 2 disjoint subtypes, 2 different discriminators. And so what we do here is first path, we choose the instrument type. For the instrument type origin discriminator, we choose instrument resulting from financial contract, and in the second path, for the same discriminator, we choose the other option, which was instrument resulting from credit facility. And there we're basically choosing between subtypes for that discriminator, but because this instrument had 2 discriminators and disjoint subtyping, our next choice we need to make is for the other discriminator. So that discriminator was instrument type origin. And here we take a path for each possibility of that discriminator, such as deposits, equity instruments, loan in advance, off balance, etc. And we'll see, because this was a choice, if you like, there was 2 disjoint subtypes, that's why this is not filled in as blue. But let's say we've chosen this path, loan in advance. Here it didn't have 2 discriminators, it didn't have disjoint subtyping. It just had normal subtyping under one arc, we could say. And there we just make the different choices that were allowed for that. So loan in advance, one possibility was advance, one was loan. These are possible values of the discriminator, and also they relate to which subtype we choose, because there was only subtypes for that. Then we could say under that we actually do have disjoint subtyping between whether it's syndicated, non-syndicated, and also different subtypes. So here we choose first and subtype, either loan, that's a choice of one discriminator called loan type, and then we differentiate between the 2 subtypes that related to syndicated and non-syndicated. Now let's click on here. What we're saying here is we've made a choice, and we neatly, concisely describe that choice as instrument type by origin was instrument resulting from credit facility, the instrument type by product was loan in advance, the loan in advance type was loan, the loan type was other loan, and then the syndicate was non-syndicated. We can also say approximately, it's not always accurate, but what the related input layer column would be for that LDM attribute. But we find it's like 90% accurate, it's not always completely right. Now, why is this useful is the main question. What we can say is, if you're dealing with something that is basically has these properties, then if we want to create, say, a piece of test data for that, we only need to fill in the could say these five, well, basically what has been decided by these five things. And we can look at that by saying view all attributes for the path. And we'll see all we need to populate is these as the instrument entity, which has these things. Some of these are links. You could consider them as foreign keys to other things, like if it was hedged by an OTC derivative. Also here we try to put the input layer related columns. Then what's required for instrument resulting from credit facility, loan in advance, loan has something like nominal amount. We actually know the loan type discriminator. And other loan has things like revolving loan indicator and repayment rights. So this is a much smaller set of fields that you need to populate for that specific piece of test data for this kind of other loan, for example. So this can be useful for creating concise test data, but also it can be useful for ETL because you can consider in your source data set, maybe your banking data set uses a different data model from different vendors, etc. And you can consider in that data model, what's the result of a neat filter on getting just the things that result from credit facilities that are loans in advance, that are loans or other loans, and that are syndicated. So it should be possible to have a query on another source system using these kind of filters to get basically this kind of information as I got a slice for ETL, so you need to get all of these things in that case. So we have another presentation on that later, but it can be useful for ETL and test data, and I think many other things. It's an interesting way to split your LDM into lots of flat, if you like, cube-like slices. And because this has a hierarchical structure, you might even find that sometimes you don't care about this level of detail. Maybe you only need, maybe you don't need all the basic details of the other loan if you're dealing with something that's more focused on instruments. And then you might just choose something that's higher up in the hierarchy. So let's say here, it was just at loan and advance level, for example. And there we say we have sort of less attributes required, depending we're only interested in sort of that more higher level of detail. So I hope you find that interesting. This structure can be useful for doing various kinds of analysis, as I say, primarily to help with ETL and test data, but it can be useful in other ways also, and also help you to understand about the logical data model. So thank you for watching. I hope you found that interesting.